Hello, New York. Well, we are going to talk about untrusted code and autonomous mind. It's basically a fancy topic. But first, let me tell you a short history. Some weeks ago, I had a problem with electricity in my house, and we hired a pretty good electrician, a professional, the most professional in the area. And when the guy was in my house, I showed the wall and I let him work. And some minutes later, I returned to the kitchen and I saw the guy, the electrician. First, everything was working okay in the house. He fixed the problem. But when I saw him, he was with his hand inside of my refrigerator, drinking juice directly from the bottle of my family drink juice every single day. Was crazy, right? But that's the same problem that we have every single day with the AI. We install agents, we run agents in our laptops, but they do what they want, and we don't know what they do. And that's the problem that I want to fix with my talk. And first, my name is Recio. I'm from Dominican Republic. I'm a Docker captain and cube astronaut. And yesterday, some guy asked me, what is a cube astronaut? And well, I think it's a guy that spent a little fortune in certifications, right? That's the reason why I'm using my jacket today. And let's see that diagrams, that architecture. This is what is happening today with the agents that we installed on our laptop. They had access directly to our SSH5 and our kubeconfig tokens. And through that information, they can have the access to the different environments of Kubernetes that we manage on premise or in the cloud. And it's a big problem. And how we can fix that? How we can manage that situations? Well, and the good news, the history basically is not a new problem. Unix handled that years ago. And in 1979, Unix started with the SSH root to fix the problem. And FreeBSD in 2000 implement jails to fix the problem. And years before, Linux and Google, thanks to Linux and Google, put together namespace and C groups to create Docker and containers, basically. And containers help us to isolate process and software to run in our machine or different Kubernetes or Docker environments, but the problem was still there. What was the problem? The software can send system call to the kernel, to the operating system. And that's the problem that we have with the agent. Agents can have access to the kernel capability. And how we can manage that? Well, because Linux kernel sends more than 400 system call to the kernel in different ways. Mac sends more than 5,000 call. And that's the way that the agents in our laptops using terminal editors can create code and sends different system call. System call basically is the way that we can communicate with the kernel. It's a low-level communication with the software. And how we can manage that? Because an agent that can execute process using the same ID of the developer or the same ID of system root in environment can create and steal information and send that information out of our network. And the way that we can fix that is basically treating agents not like chatbot. Agents is more than generate text. We came from using LLM plus ChatGPT. Everybody knows ChatGPT, how ChatGPT create text. But today, we are generating software in minutes. Big system in minutes. And understanding our enemy in the different environment, we can now isolate that. And the enemy is the AI agents. And the strategy is isolate the different system call using sandbox. Sandbox basically is the strategy that we can, the strategy and the different software in the market that let us push application in a small box to handle it and isolate it, the system call. The difference to problem that we have today is with the developer in the Kubernetes environments, because developers are using Cloud Code, Anti-Gravity, and different tools that create agents and have access to those environments, and developers are not system experts. They thought, and we thought, if we put the agents in the different either into a folder, we can mitigate the risk, and no, that's not true. Using Kubernetes in different environments, we can implement gVisor or Kata Container to isolate the system call. We have a lot of tools, and that's create another problem. How we can create governance around these kind of tools to create the standard in the company? Well, Docker is there. We can remember when deploy software in different environments was crazy, and Docker was there. Now we got the same problem. How we can run AI agents with the fears or ransomware? Well, Docker Sandbox now is the problem. Docker return to us to give us the solution to resolve the problem around AI agents. Docker Sandbox let us create a strategy basically using micro VMs in the laptop of the developer to run in hard isolation all the software that create the AI agents and create this architecture in the laptop developer, create that box using micro VM strategy, and we can handle all the communication out of the box of the micro VM and capture all the system call that the application sends to the kernel, because they're going to have their own kernel, and that's the yellow mode. This is the interface of Docker Sandbox. Pretty easier to use. And around all the strategy, the AI agents, we got different tools to manage different problems. And how we can create that governance around all these tools, basically. Manage the AI agents with their own identity, using software to identify the agents with authentications and observability to see what is happening. If we have a micro VMs, but let me see what is happening inside that environment, we can use eBPF to do that. And basically, in a short history, that was basically my talk. Thank you.